Welcome to the panel, talking about GNU Radio 4.0. This is, in many ways, an opportunity to interview and discuss with people who have been most active in the GNU Radio architecture team over the past year. There are people who are not here, unfortunately, who have been jumping in and out of the conversations remotely, particularly people at FAIR who couldn't travel over in bulk, but hopefully we'll be able to have some more discussions. And I don't know if we've set the date for the next architecture. We have not. Soon. We'll have one.
So my recommendation.
Microphone.
So yes, to join the architecture chat, which this is generally a subset of folks that are involved in that. On the Matrix chat, chat.gnuradio.org, there's an architecture room, #architecture. So join there, and that's where you get the information about the next chat. So sorry, Derek.
No. So that's how we can join, and they're both held as asynchronous conversations in chat. There have been some emails bouncing around, certainly, when longer form discussion is needed, and then when you really just want to hash out a concept, we do semi-regular calls, video calls. And so please feel free to drop in on any of those and contribute. So let's start down from the end, just with a quick introduction of who you are, and particularly in the context of why you would end up on the panel here.
Jeff Long, the GNU Radio 3.x maintainer, and so my interest is keeping the transition to 4.0 smooth when it happens, and understanding how we're going to maintain blocks across the versions.
Thanks. So I'm Markus Müller. I used to be the maintainer like 2.5 years ago. So I'm still trying to get a bit of a picture in my head and contribute.
Yeah, Alexander Grimm. I'm working at FAIR, and in that capacity, I'm working on some of the aspects of this graph prototype that will hopefully soon be merged into GNU Radio Dev 4 branch and then become the new GNU Radio 4.
And I'm Josh Moorman. So I've been involved the last couple of years, various aspects of maintenance and the iterations that have been on this path to GR 4.0 up to this point.
I'm John Saleh, and I talk a lot about PMTs, and I've been working a lot, FAIR's been doing most of the work, but helping to make sure that everything interacts well as we move forward.
Hello, I'm Ross Steinhang. I work for FAIR. And if everything is good, that are these guys. If something is wrong, that's me. So you can ask me stuff about what could be better.
How broadly can we apply that to, if the food's bad, is that your fault? So I wanted to start with a bit of a reflection. I mean, the fact that we're all here in this conference now, an opinion that I hear fairly often is that GNU Radio 3.10 and even 3.6, 3.8, 3.9 are good enough for your application. So what would you point out towards some of the strengths of GNU Radio, of these various 3.x versions, hopefully 7 and above, that are properties that you think are intrinsic? Like, what makes it GNU Radio in your mind? Starting with anybody who would like to.
Okay, since I already have the microphone, obviously, like, what GNU Radio is you take a block, you connect it, and then you hit run, and it runs, right? So the two main things are blocks and that you can connect them. And to be fair, like, it wouldn't be GNU Radio if this was LabVIEW, which, allows to do the same, and Simulink does the same, but it's very easy to actually write a block, go in there, and do something. And so this is a very core idea that you can give anyone who has like this engineering or this technical or this tinkerer approach to things. I do this, and then I do that, and then the result is this. You can very nicely represent as a chain of blocks.
It's also a community, a bunch of online resources, the OOTs you can find around, and applications like GQRX that you can find various places. So kind of broader than just us.
I'll also mention accessibility. I've used a handful of other signal processing frameworks, and it is really nice that GNU Radio, like, you need some sort of RF background of knowing what a spectrum nominally represents. But GRC is a really valuable tool for people, and you don't have to have a bachelor's or a master's degree in engineering to be able to use it and do useful things. And that's a really powerful feature of GNU Radio.
And I'll add on to that in terms of accessibility, that there's varying levels of accessibility. So you can just string blocks together in GRC and make something work instantly. You can make, little Python blocks in GRC without even leaving GRC. And then, all the way down to, you can make very complex C++, hardware accelerated blocks if you'd like to. So the gamut of, where people are able to fit GNU Radio into their processing workflow is pretty diverse.
Don't forget, I think we have Fortran hiding out in one corner
it is.
of the code somewhere. Yes. So those are some of the pieces of what makes GNU Radio, and I would certainly agree with many of those there. In addition to it being an open source project and as you say, community developed, I think it's a really good point to say that the ecosystem is an important part of GNU Radio. And when we say, oh, we're going to rewrite the code base and we're going to break everyone's blocks, everyone's flow graphs, that's a dramatic statement. And if we're saying that ecosystem is an important part of GNU Radio, then that transition is really going to be a key part of what makes this possible to call 4.0 GNU Radio. If nobody can make that hop, then we should really rebrand and say this is, we have old radio and new radio. So what do you think some of the weaknesses are? Why do we want to go to 4.0? If that transition is going to be hard to develop and hard to jump, or at least work to do so, what makes it worth the while? You can't voluntold somebody to speak.
Yeah, so as much as we've worked on GNU Radio 3, it's got some stuff that's fairly difficult in it for anybody who's tried to understand history and forecast and a bunch of other things, and tried to get really good performance and low latency out of it. So yes, we can explore signal processing, put together some projects fairly quickly, but what we want to be able to do is have you be able to use GNU Radio all the way into your final product, and that's where we fade off a little bit now.
Yeah, absolutely. There's just a lot of design decisions that were made that might have made a lot of sense back in the day, but were grandfathered in, and Ralph went into that bit. There were things that I can't simply explain, right? And there are things that I would say were architecturally not a good decision, but given the programming tools and the knowledge of the community at the time were understandably done. For example, everything you handle in a GNU Radio, using application is typically a shared pointer, which is a great thing if you actually share that pointer with multiple threads, multiple consumers need to ref count, but it's usually not a good architecture if someone actually knows who owns a block. It should be some specific thing and not something that at some point might disappear or not disappear if it's held by Python or not. So there's a lot of architectural things that I wish we could solve in the 3 series, but the moment we actually go in there and solve that, we're changing the API very fundamentally, and then we might as well, fix another couple of things on the go.
Yeah, so last year when I was at GRCon, I did kind of an informal polls. I met various people, and I asked, are you using GNU Radio for prototyping, for production, or both? And one person said that they had one really oddball application that they were using in production. But pretty universally, people said, we are using this for prototyping, and then we go and we handwrite everything into the production code. And so FAIR is doing a really good job of thinking of how can we close that gap and make it really easy to go from prototype to performant, secure, and usable, maintainable production code.
As a quick poll here, if people could throw up hands, who is using GNU Radio in a deployed application, in something where you would say, maybe it's not a sold product, but it's a developed system that you consider as the final piece of that system? Okay. Yeah, that's reassuring that there are some hands, but unsurprising that it's not the entire room. So that, for the folks on the web stream, was probably 15% of the room, 10-15% of the room. So good, and let's get that number up in a couple of years. So I want to ask, are there any questions from the audience at this point? We'll jump back onto some other prepared ones, but we have lots of technical pieces and that we saw yesterday and lots of theory that we've talked about. What questions do folks have?
So, first of all, I do have a roaming lavalier to help with questions, if you wouldn't mind waiting for that. But I do have a question. So, for all the people on the stage, can you raise your hand if you're, as you know, working on 4.0, you're focusing or you have a lot of focus on usability? Okay. So, and ease of use. Could you give some examples, like, brief examples of what it is that you're doing to make sure that it continues to be usable for those of us who don't necessarily want to code, or I think the great example of not necessarily needing a bachelor's or master's.
I think about, and I want to echo again, because it was like a very important message that Jeff made. This is about the community. This is about you. And we want to preserve what is good about it, especially what is the UI interaction and stringing of graphs. How I consider this is a bit like a house. If anybody of you is a house owner, like you build a house, but every now and then you need to do some maintenance. You have to exchange the gutter, you have to exchange some paint, and sometimes you have to do a bit more changes because some bars rot away. And that what we just did is the house, which we all use and we're happy with, works well. But it's still a continuous commitment to renew it and make sure that it also worthwhile for the next, not just the next 5 or 10 years, but that we have an easy maintenance, that we not just say okay, this is beyond help. We have to throw everything away and always start from zero again, and that this happens again every 5 or 6 years. We want to bring GNU Radio in a way that we can make incremental changes which are easy, transparent, where nobody says oh, I don't want to change this because I would have to change the whole code bases, where people feel comfortable maintaining and using it. And in terms of usability, from the graphical concept, ideally people who just use the UI shouldn't see no difference. That should be identical. Most of the stuff that we change is under the hood. If you're a block developer, this should be significantly simpler because you just have one single place where you have to write your block. The single source of truth is the few 10 lines of code you need to write. What I showed in the slides yesterday, that's not like slideware where it's oh, I took just the conceptual things. This is full production code. So what took earlier hundreds or 200 lines of code to write a simple block is now literally 6 or 7 lines. And that is helpful, even in very simple C-style lines where you don't have to know too much about programming. You can just say okay, that's a function signature. This is my input sample. And I know this return statement, I have to put my output sample. And then the rest is basic math that everybody can do. And that is fundamentally important, that even if you don't know the GNU Radio ecosystem, and you want to write a block, you don't have to read a lot of documentation because most of the things will be obvious because of the block structure as it is. So it should be intuitive. And that took some time. And there we also need your feedback, because in terms of naming, to see what we showed yesterday, is it intuitive? Or you say oh, that's a concept, you need documentation. And for me, it's always the more documentation you need for a concept to explain, that shows me also there's a deficiency in the design. You have to reiterate and make it better. So that basically, somewhat freshmen from university within the first week can hit the ground running.
So we've got does anyone else particularly want to respond? No. Let's go to the next question then. And let's not stack the deck too heavily. We've also got a question down at the front.
So I'm actually relaying a question from the internet, specifically from Barry, whom we all know and respect, and he asks, how will 4.0 affect documentation such as the wiki? And I'm going to add a little thing myself. Ralph, maybe you can comment on the way that inline annotations will affect documentation as well.
That's a big thing. I hope. I mean, like, we have to preserve what is there, because there's like a lot of institutional knowledge. I think in terms of the general usage documentation, most of this applies one-to-one. Maybe obviously like the low-level API is different, but I think what we did is with this inline code documentation should making writing blocks easier. So you don't have 2 or 3 places where you need to maintain code, but just documentation, but just one. For the transition, we have to see with the wiki specifically how we make it clear. Now you're looking for documentation for 3.10, and what is the documentation for 4.0. So maybe we have to add like a bar, like some visual indicator. This is like the existing production code, and then in one color with a bar, and the other one is 4.0 with a hint, depending on which version you use, that there might be some documentation that is different for either.
Yeah, I'd like to add to that we already do have the capability in the wiki to say this applies to version 3.7, 3.8, or 3.10 specifically. We can just extend that, like just saying this applies to 4.0. That is certainly possible. The good thing with our wiki is that, you know, this is all our infrastructure. So if we decide that for now we need to have, like, we migrate all the block documentation to say a different domain and say this is the docs.generator.org domain, for example, and we have the block documentation there and a specific wiki that might actually be a new one, we can do that. So I'm not a fan of splitting documentation because it gets out of sync, and we had a very nice discussion on the docs channel on the Generator chat server. So, you know, obviously I'm advertising this now. There's a docs channel, #docs on the Generator chat server. If you're into, you know, improving documentation, if you have questions about the documentation, rather about the thing that is documented, then that would be a great, you know, we'd love to see you. It's very hard to actually good technical writers to get people to proofread documentation, and that's hard enough. So I'd say probably this is, you know, not something that I can enforce or want to enforce, but I foresee that the wiki is not going away. We're going to be better about marking which is which and which applies to which version. And I think also this might be something that we put, you know, specific effort into, is linking the API generated docs, so something that our compiler and build infrastructure spits out, better to the documentation that is in the wiki and vice versa. That is very reasonable to do. There is some kind of difference in what you would write into a block doc instead of a wiki page. And I think it would be good if we had some guidelines on how to do that for all developers and all documenters to apply.
I want to put out as a milestone for us for 4.0 or maybe, you know, 4.01 that every block should have an example flow graph. And also to point out that, and acknowledge and thank, that ARDC has actually funded testing all of our existing example flow graphs and doing documentation work. So thank you to them, and hopefully that'll be feeding fuel into this effort and letting us make some of the jumps that, you know, have an energy state level just a little bit beyond what we seem to reach in our resting state.
So I maintain some OOT blocks, and when I first started it took me a long time to figure out how to do some things, even though the code was right in front of me. Like, for example, if you want to add a variable to a block, I needed to modify the YAML, modify the overall header file, modify my header file, and modify my code. And it took me quite a while to figure out that I needed to do all those things, and even though I was getting errors at various places. So is 4.0 going to fix that, or is it, because the way you described it yesterday was all you got to do is put code here. Well, how are you adding new variables and things like that?
Why don't we spread this around?
Oh yeah, so
One more, sorry.
So you know, that's been in this path to where we're at with 4.0, that's been a common theme of, it's been a common complaint. And having that single source of truth that Ralph talked about is the direction we've gone, that you put what you need in one spot, and then there's no point, there should be no reason for a person to have to go and do all that boilerplate manually. You know, it drives people away from GNU Radio. I've worked with people through the years. They're like, I don't want to do this with GNU Radio. I'm doing this little bit of DSP. I'm just going to go, you know, write whatever my own C++ code. So, you know, we want people building things that can fit into an accessible framework that's available for everyone. So that is definitely a theme.
So that was a property in NewSCED a couple of years ago. One of your core goals was the code reorganization and having a single source of truth. So
That's being carried forward.
Yeah, and so specifically for the mechanics of that, say all the parameters to your block are stored as, is it a vector of PMTs? Okay. But there's, the constructor takes the PMTs, is that right? Or did that change?
Exactly. I mean,
Yeah, oh, go ahead.
maybe I should. No, it's better. I make some advertisement for John, because it was like was instrumental to change that. I mean, like for the low-level block writing, if you need a variable, you just declare your float, and then due to the power of compile time reflection, you automatically see that field, and when you call the constructor, you use these are automatically translated to PMT maps. So you have a key and PMT, and then it's all done for you. So if, as a block developer, you start with a struct with your name. You say this struct derives from the CRTP template. This is think of it like a std vector where you just have to add your type into this. You say you define your input port is like one line, your output port, and then all the variables and the types that you would need for if you're a C++ developer, and the rest will automatically generate the settings initialization.
That modifies the YAML also, so I
you don't need a YAML anymore.
Oh, okay.
So basically, it's only there's 10 lines of code. Everything is handled, and the beauty of that is because my experience was code generation is nice when you start writing it, and for the guy who wrote this code generation, but after some point of time, maintaining the code generator gets boring, tedious, and then people move on. And then if you inherit such thing, it's always awful. This doesn't happen in the first 3 years. This happens after 5 or 6, 7 years. And we had like 3, 4 different projects where we had this. So I said, like, if we can get by without code generation, all future maintainers will thank us for that. So we said, like, can we do it without? And compile time reflection, which we now still have a library that helps us with this, but will become a core feature of C++.
just a moment. Would it be possible to get the clock back up on the rear of the panel? The rear of the wall? Thank you.
And does anybody else on the panel have an idea how this would integrate with GRC or whatever the future of GRC is? Would that use the introspection to figure out how to make the GUI representation of block parameters?
If you put the annotation in, the UI can derive everything from the annotation. We have some helper methods where you can say, like what I showed yesterday, you have a helper method that inspects the struct and generates whatever. I mean, you could generate a YAML file from that. You could generate a PMT map that tells you, like, okay, these are the variable names with these types. You also can get, if you annotate your fields, get the description of the fields. So you can make like markdown descriptions that you can use in your UI to say, like, to replicate the wiki. I mean, like, concerning for the wiki, there's a part which you can take directly one-to-one the code documentation and inject it into the wiki. Maybe even like the examples could be also added to the code. Then the question is more how big you put the documentation in the code, or whether you say, like, certain examples you want to live just in the wiki, not in the code base. But I hope it should be, yeah, much simpler. But this is always like, if that's often like when you present something yourself, you think for yourself, oh, that's way simpler. But you guys have a look at it. You're the judge of whether it's easy or not. And so we're at the stage where we invite you to have a look at it, experiment with that. Be aware that's presently not a feature complete. No, we didn't import all the blocks that are there. So we just implemented the hard to implement bits, the MVP bits, so that you can string up already meaningful flow graphs to try this out. And then, yeah, see whether you have feedbacks. And we will still have, like, this is not like a once done, never change. This is a continuous process, continuous improvement, continuous change for the better, where you're part of and you're instrumental as well.
As a second question, I've had 310 has solved the install problems I've seen in all the previous releases. I've kind of given up installing all the other versions, and especially building from source. And in 4.0, are you carrying that forward? Are you thinking about what it takes to install it on every known platform known to man?
So I'll jump in with a leading piece here. Again, thank you, ARDC. We have a significant chunk of money, I mean like over $60,000 to address installation pieces. And as a call out to Ryan Voltz and others who do the packaging, 310 has definitely been much better than the past. So much better that we're not perfect, but we're so much better on 310 that there's actually a question standing whether we should redirect that ARDC grant to 4.0 to make sure that out of the box we're absolutely nailing it. There are already plans for it to be better than it has been, but I'll pass that to the panel if anybody would like to add pieces. But
Derek mentioned Ryan Voltz, and he's really to praise for that. He maintains. This is an ongoing effort. That's something that you do every day. The Radio Conda environment, which is basically a set of recipes that set up an Anaconda environment. If that doesn't tell you anything, that just says you can download an installer for your favorite platform, double click, and it will set up, it will come with its own Python. It comes with all the radio, the libraries, and then for some important OOTs, it also has installers. So this, I wouldn't say that is a solved problem, because the problem is, easy problems are quickly solved, and the real problems are when you then need to deploy that, say, in the company network or something. This is not a solved problem, but what we can do basically is make the software easier to install by not being absurd about its dependencies, and I think we're doing a pretty good job in the last couple of years about that. And that's also like, I remember the 3.7 to 3.8 transition. That, we got a lot of headwind, understandably, from people that used GNU Radio 3.7 and were very dependent on that continuing to work. And we were like very sorry, but we could not support, we couldn't develop 3.7 forever because it was depending on things that simply died out, like Python 2, Cheetah, and other components that simply were not feasible, literally not possible to supply. And when you redesign a software and write it from scratch, you get to choose what you depend on. So obviously we're not starting with, yes, this is the full boost installation that you need to build this. And that makes things a fair bit easier, but it is an ongoing effort. And I don't, Josh, you would probably agree if someone says, hey, I have this cool new feature that I want, but it makes us depend on libverycool, and libverycool only exists for Windows 3.11 and Linux 2.6, then it's not going to end up in tree. So that is something that we can ensure, but it's not very much an architectural problem. It's more a maintenance, environment, talking to people problem. Right? This is very much a communicative problem, because hard to install is always, someone made it run on their machine. So in absence of the opportunity to ship their machine to everyone who wants to use it, it's just about communicating what is an appropriate way to make things work. Now, usually we're getting better about that.
Yeah, and so Ralph, do you have comment on the portability, the lack of dependencies in the graph prototype?
Yeah, that's maybe I would just want to say I'm a dependency Nazi, because I said, for me, zero dependency is the best dependency. There were some dependencies that we couldn't avoid. For example, we wanted to use FMT formatting library. We accepted that, just to give you an idea, because we knew this will become, or is now part of the C++ standard. We just used it as an intermediate dependency because not yet all compilers supported that out of the box. This will be one of the first that we drop. And the other big dependency that we have inside, but which we could incorporate, is FFTW. For every dependency we put in, you have always to make the trade-off: how much benefit does it give you, and what type of maintenance nightmare it gives. And if in doubt, we rather choose, because the library on the low-level end should ideally not depend on anything other that is higher level. We had the problem with the boost, also in our facility, where you had different libraries having different versions of boosts. And if you want to link them together, that's a nightmare. And we never want to go back to those type of problems. So the idea is that the core, the lower you are, the less dependency you have. So the core library will ideally have no dependency, with maybe the exception of FFTW, because rolling your own, I mean, we wrote also our own FFT implementation, but this 50% performance boost, I thought, like, I don't want to give up performance on that, so they made an exception. The second thing that we made for portability was we aimed at both compatibility with GCC, Clang, and MSVC. We have some collaborators that also compile it natively to Microsoft and Mac, and we hope that this will help for the packagers to have the same less if-else if you're on this platform or that platform. And the third ingredient is it's largely header only. So you don't need to package necessarily. If you say you just use compile time graphs, there's still a SO dependencies if you want to use it for GRC and have a compile time, runtime connectable graphs, then you need an SO. But otherwise, we're very aware about that. And that's our contribution also as a large-scale deployment, because we have hundreds of those, and having heterogeneous dependencies is a nightmare.
And to add to that, we do need to be a bit self-critical there, and I think we fairly are. It's that we do have a dependency, right? It is a modern C++ compiler, which is, that's a steep call to make if you're trying to compile for Zync in specific circumstances. But that's the thing, right? We're not developing the software for end of 2023. We're developing the software for end of 2023 and the 16 years after. So that is, you have to go a bit forward in dependencies, just to be sure that in a year you're not regretting what you're doing now. That's the one thing. And you mentioned that 3.10 solves the installation problem, and I thought, like, where does that come from? And one hand is like Radio Conda by Ryan Walls, and the other thing is probably that, through Radio Conda we got all this CI that actually builds on Mac OS and on Windows, and we do catch bugs. We actually caught a lot of bugs when we introduced that we didn't see in our continuous integration tests every time we made a code change before. And because a lot of us, don't actually work on every platform, it took some time before to detect that. And if you knew GNU Radio before we had the CI running, you knew that bugs could, be in there for a while if no tests are run against them. So that might be the reason why we're getting better at this. And FAIR certainly doesn't write much software that they don't test before they deploy.
Thanks, Marcus. Yeah, just
Yeah, sorry. I was rambling on.
It's not a Stack Overflow answer. So I know we have another question there. We'll get you in just a second. I did want to kind of jump in and insert a question, which is, in terms of user interfaces, there's been some discussion, which I don't think was really covered in previous bits, about the difference between the computing flow and rendering out, a user interface, and whether there should be a different separation. Will we keep using Qt, GRQT GUI, or is there interest in doing something different? Let's start with Jeff.
Yeah, so we saw some interesting talks earlier, like Luigi's talk, and stuff with web. Using ZMQ to pipe out to other programs. And I think part of the solution will be making clean interfaces where we don't have to build it all in. Because going back to your question on dependencies, we do depend on Qt. The new video sync that's going to go on and depends on a specific package from Qt. So we don't totally, the core doesn't control all of the dependencies. We still have to be careful of that at the broader project level. But yeah, I think if we can make some standardized ways of transporting data in and out, whether it's shared memory or ZMQ, and make that really easy to use, that'll help with the GUIs too.
Great. Okay. Yeah, let's go to a question.
Yeah. One of the questions I've got on the floor is, can you guys please make good examples? Because 4 is a whole different paradigm, and then I have no idea what to do, and it really helps if I can see an example that I can simply understand, and I start building on that, and that builds the confidence to build the more complicated blocks. So please document it and give us examples, because otherwise we're going to give up and go somewhere else.
Do you have any examples of examples, that you're thinking of?
Well, one thing that would be really nice is I build RF hardware, and if I have to instantiate a new device, it's hard to do because I have to go and talk down to my hardware. And what I would like to see, if at all possible, something that has a simple socket interface, so I don't have to build a complex interface. I can just get the data in on a simple socket, something I could implement in an FPGA, for example, like a UDP socket or something, and have, I can give you a stream of int 16s or int 64s or whatever. Can I get something that can interpret that and bring it in into a flow graph, and likewise have simple controls going back, so I can, if some variable is instantiated, it gets converted to an int 16, and I get a variable, like a token value and a variable back into the hardware. It would really help us who do unusual and strange hardware, which have ultimately become new products. So it's just please, we'd like some help.
Yeah, sure. Absolutely, very important point. We try to always have like a full vertical stack integration. That's also the reasons why we have our own UI, just to make sure if we build something that we also can integrate it from the bottom up, also for the driver integration. While we have this, also as part of our unit tests, this is just on a technical level so that we can show it works and that there are no gaps in the technical implementation. And this is like where we need help, where we need like good technical writers, because most of us that develop that are good C++ developers and library developers, but in order to transit it to also like for the wiki page, we need help for somebody who takes this and forms, let's say, like an educational path where transforms it into something simple. This is my Hello World full stack program, and then makes a gradual, let's say, gradual complexity increase for each of the examples. Most of our examples now have something Hello World, but then the second one, the example has all the rest of the features, which might be overwhelming, and we need to improve on that, having more technical writers and people who experiment and bring also a bit like didactic into that. And yeah, I think that we need help.
Yeah. And
Are there any other questions, just so we can run a mic? Okay, great. Already said.
yeah, and so one thing I'll add to that is, one thing, since we've made this this diversion, not diversion, it's the path to the GSI FAIR code that is the basis for 4.0. The reason you're not seeing that right now, like in the GNU Radio repos, is, a lot of it is the lack of examples. We don't want to say, here's the GR 4.0 code, and then it's not accessible to people, that it's this academic thing, because it is going to be GNU Radio 4.0, but we don't have it to that point yet integrated as something that looks exactly like GNU Radio. So we don't want to lose people in the process there. So just a heads up, that's why it lives right now in the GSI FAIR code base. But once it migrates into the GNU Radio code base, will be structured in a way that you can build flow graphs with it and do very concrete things.
You've already just kind of started answering the question I was about to ask, but Ralph, I know that for you and your team, one of the next steps is to implement the selector block, which was something I had asked for as a nice minimal example of a block that has slightly unusual behavior compared to just a samples in, samples out on single ports. Also in your presentation, I saw you use quite a few picoscopes as your digitizers. So at what point do you think you might start implementing support for something like that in the 4.0 and graph prototype? And then more broadly, for each person on the panel, what do you think next steps are to get us from where we are today to code being merged into the GNU Radio repository, and then eventually winding out to a release?
In the selector block, our project is openly developed. We have a project site with a Kanban board where you can see which are the items to be worked on, which are the pieces that are already implemented, which are the ones that need to be done, and specifically the selector block. That is where Dr. Ivan Kucik, I name him also as doctor like Matthias, because he really deserves the doctorate. And he's developing it, and maybe either today or Monday, this is also in the code base. There's some, we plan to transfer this into the regular GR repository, but there were some things where we need to change naming, code formatting to clean up a bit before we present it. I mean, you can see it already now, it's not hidden code. But there's some housekeeping that we want to make sure that, that everything is smooth.
So to answer Derek's question, so these guys have been doing a great job focusing on the C++ foundation and the core of GNU Radio. I'm very excited for when they get the Python bindings in, because then we can start saying, okay, now I'm going to write my Python flow graph or try and pipe it into a GRC-like thing and see where the rubber meets the road there, see what things maybe got overlooked or what improvements are there, and that'll be a great opportunity to really stress it and see how it works for the typical GNU Radio use cases.
So in terms of next steps, once we're able to get this into the GNU Radio repositories, having a clear, well-defined structure of here's where we're going to put blocks, mirroring how they're going to be out of tree, and where it really starts to look like GNU Radio that people can understand and access it. I think that's the next step. Even I'm very much looking forward to the Python bindings as well, but I think there's also a lot, even with the C++ code base that can be done that we could, I don't think that will be the 4.0 release, but we can go a long way with C++ flow graphs.
Yeah, I'm thinking in a similar direction, because the state of the prototype now is that there was a lot of the problems are solved, but they are solved in the place where we solved them. And now there's this step where we have to get all the blocks into a directory where the blocks live, and make sure that every feature is compatible with the other one, and it doesn't get overwhelming if you use features at the same time. And so once we have that figured out, and this is a little bit hard to do while you're constantly adding new features, because some people are working on a feature, and then if you do this complete refactoring and moving stuff around, that's why this was like on hold for a little bit, but I think we will do this really soon to get it sorted out, and then I think it can be merged pretty soon.
Yeah, I think I do agree with all the above. Basically, we do have a couple of projects that are very forward-facing, where we're still working on 3.10 or the 3 series. We have, what I will do is go over the bug tracker of the last 10 years and figure out which ones, which of these bugs are things that we need to think about in the 4.0 development process. That is the official goal, I guess, a bit. And the other thing we have is that GRCon is currently rewriting GRC, right? And he's gotten pretty far. So there's a Qt rewrite of GRC that has very technical reasons. And we'll need to figure out which front end we want to put, to 4.0. I don't even know whether it's going to be the 3.7 series GRC or whether we, end up finding something else. But either way, we need to figure out which are the takeaways from a couple of years of GNU Radio 3 development that apply. And the other thing, and this is very much like me, is communicating how it's done, right? And I usually take the road of just writing a bunch of mailing list posts, going on Stack Overflow, answering questions, and getting the examples out in the world where people actually then refer to. This is very dangerous, because unlike a wiki where I can just, edit it in 2 years when I figure out I was stupid, something that was on a mailing list, the internet does not forget. But on the other hand, it's the only way to actually deliver an example that fits someone's use case and explain, hey, you had this problem, so here's how I, as a GNU Radio 4.0 developer, would have thought about that. That's the only way, is actually going in and doing free consulting. kind of. So yeah, that is what we're going to do, and it's going to be a lot of work just communicating about how things are to be done or typically are done. As usually we figure out that there's more than one way to skin cats. My apologies to cats. But yeah, if we don't start discussing this in the public, we will not crystallize this golden way that everyone agrees, is a canonical way of writing something.
As far as milestones, I'll be excited when we can build a full digital receiver, complete with clock sync and data.
Great. Thank you all. So we had a question at the back.
Hello. One of the other reasons, in addition to performance, I think why GNU Radio doesn't get adopted for production code is the licensing. And are there any thoughts as to making changes to the licensing, and/or maybe just thoughts from the panel on why that concern is wrong?
Maybe I can say for FAIR, this is specifically now the FAIR position. We want to interact with industry and the open source community, because we saw when we put out technology that is freely usable, the tendering process for private companies for working with us is much easier because they can assess better what is the complexity. For that reasons, we choose a liberal license like the LGPL, and this is also our code base. We contribute as LGPL, even if it's then relicensed to something else, because we feel it's important that this community and also industry in engagement, and to have it as flexible as possible. But this question is to be have, because maybe you do.
I was smiling at the question there because in the car and last night we were talking about the licensing question, and it's been something that the architecture team has been talking about, and this is certainly not a new one. We just relicensed Volk to LGPL, and that was something that we decided was a really pragmatic answer. It is a standalone library, and the virtue that we really cared about was that if somebody received an application using Volk, that if there had been enhancements made to that Volk library, that those enhancements would be available to the end users. And so for me, that virtue applies to GNU Radio as well, and the LGPL does largely convey that. There are issues for me around out-of-tree modules and how that interacts with the LGPL license and end users, but that's a discussion for the community to have. There's no one person on this panel or the whole panel who can make that decision alone.
Exactly, and I think one point I'd like to drive here is that the kind of from scratch implementation that Ralph and the group at FAIR is donating to this project is coming in as LGPL. So it gives us options we've never had before. So GNU Radio 3 is a GPL v3 code base, and you can't change that. You can't do anything about that. So it is an ongoing discussion that will happen, that we do have the option now to do something differently.
Anyone else on the panel want to bite into this one?
So GNU Radio has a lot of different layers, and we may find that we need to maintain some of the code in the middle layers in order to keep everything from changing, and that code will be GPL. So already, a lot of people don't understand that the GPL just means you provide your code to whoever you give the binary to. And so in a lot of cases, just knowing that solves it. If you're not willing to give out your code, then obviously that's a problem because you're linked against GPL code. So if you're creating a new block that where the only dependency is the 4.0 core, then you will not have that restriction. You can have a proprietary license.
If the core is LGPL.
If the core is LGPL, if the full core is LGPL, and the fact that the FAIR scheduler, is currently LGPL, does not necessarily mean that what we think of as the full core will be LGPL. So, to be determined.
It is a spicy question, but it's one that needs overall discussion and everybody in here. So that the workshop and is that an online question? Okay, great. We'll get to that in a second. That's something that I imagine there's probably a little bit of room to talk about during the workshop today, but a lot of room tomorrow and a lot of room in the architecture chat meetings throughout the year. We're still at least months away from hitting a point where we need an absolute decision, because there will reach a point where there will be GPL code that will be very straightforward or natural to want to include in, and we need to decide if and how those are getting merged and divided as necessary or isolated as necessary. But you're far from alone in being interested in this. Let's go with the online question.
Unfortunately, I don't think it's a very short question, but I'll try. So it's Franco Venturi, I believe. And the question is, after watching yesterday's presentation, it seems to me that there's a significant amount of overlap between the vision of GNU Radio 4.0 and Bastian Blossel's project Future SDR, except for the choice of PL, modern C++ versus Rust. How do these two projects compare? Are you planning to work together with Future SDR and to find some form of synergy, or do you have any other comment to make about this?
Yep, I'll go ahead. So Bastian wrote Future SDR because he was, frankly, kind of tired of the GNU 3.7, 3.x series problems, and he also wanted to practice his Rust. So this is a slightly different motivation, I guess, but he did, show that there's a lot of very cool patterns, and we were sitting in a Hackfest together. He was showing us how he implements some blocks like within minutes that would have taken in GNU Radio 3 half an hour to do. And that was really, really cool. I do advertise and recommend you look at Future SDR just to get to an inspiration what software can also look like. So it's a cool project. It's not, I don't think it's a competitor in the course in the strict sense. There can be more than one SDR project. It's also like run by one guy. So this is a bit different situation on the community thing. And Bastian is part of the architecture chat. He's been a long-term GNU Radio contributor. He's been very influential in a lot of later 3.7, 3.8, 3.9, 3.10 architectural changes that were possible within the GNU Radio 3 series. So I don't think this is a bad thing at all, or we need to think of this as something that might split the community. Quite the opposite is true. Basically, and there's also something very nice about both Rust and the project, is that there's nothing stopping us from embedding Rust code into our stuff, or vice versa. We might even plug, and this is I'm very excited about that opportunity. We might be plugging his scheduler into our scheduler framework if it's a cool thing, right? And if that works, I'm fine.
For the scheduler, maybe that's one of the differentiating features. The Future SDR still follows very much the scheduling policy of the 3 series, which is a microservice-style scheduler. For high-performance computing, this doesn't work. So we made a work scheduler, so the scheduler is substantially different, the orthogonal implementation. The block implementation maybe can be shared or make wraparound, but the low-level scheduling infrastructure is different. And these are like 2 experiments. I mean, like you could say if you just care about schedulers, you have these 2 paradigms. One is like a work scheduler, and the other one is like a microservice, like an OS-style task thread scheduler. And we have to see, like in the field, which one performs better.
I'll put out as well that I've been thinking a lot about allowing developers to create blocks in other languages such as Rust or Go, and having those integrate in. And that is one of the topics that I wanted to discuss and get feedback from people on tomorrow at the GRC format workshop, is making sure that we have a format for describing a flow graph that enables blocks to be written in whatever language, so that we wouldn't have to go in and do a hack after the fact.
We are at the end of the slot, but I want to go down once more and ask for any kind of concluding thoughts or dangling threads that we didn't get to, and tacking in something else. What do you hope will not be in GNU Radio 4.0 but you look at it and say, as we're looking at 4.1, there's this feature we're not going to get to, or this language feature that's not available that maybe we can take advantage of in the future. And I'm thinking specifically, Alex, you may have some thoughts there. But please.
I'm going to pass on that one.
Maybe not.
So I think like we're getting to a very cool thing. When I was young and hopeful, and we were having like a workshop on software radio in Karlsruhe where I studied, I've been talking to to Jonathan Corrigan back then, and he was very excited, and I'm still very excited about fully RPC set up flow graphs that where you can deploy this automatically and stuff. And this is the kind of tooling that you develop over time, which you don't get right on the first thing, that you actually need to know what your user's gonna do. So this is naturally something that comes later, I think. We might have something in the early versions, but I'm pretty sure that will change over time.
So I think that to echo what Marcus said, a lot of the tooling make it easier to create blocks. If we look forward, maybe there's even easier ways of creating blocks than grmod tool or that single source of truth. Add in some natural language processing to create blocks, things like that. But am I off? Yeah, no, I'm good.
Okay. So the thing I'm really excited about that is the potential for new ways of running blocks or flow graphs. So I would love, if I'm writing in Python and I'm doing NumPy and SciPy and I want to run a GNU Radio block, I would love to just be able to run that one block and pass in a NumPy array and get a NumPy array out. And that's difficult to do right now. And so that would be a really cool application to run a block outside of a flow graph. And I think that the system that FAIR has set up should easily enable applications like that. And so I am excited to see what applications the community can come up with and novel ways of using flow graphs that aren't possible now, but the modularity that they're enabling will allow in the future.
I think for me, GNU Radio is about you. It's about the community. And for me, it's important to have a fun project where people like to use, where it's intuitive and very high performant. And that should be the driving factor. And it should solve a concrete, specific problem of you without lots of boilerplates or burdens. So I think that's always important. And on the short term, to pick on that, we want to support Python. It's not that we say like, oh, we didn't put it back because we didn't want to, but we wanted to wait because now is also like a very good opportunity to reflect upon how do we want to interact with Python in this ecosystems. Do we want to copy the same paradigms of 3.7, 3.8, 3.9, 3.10? Or do we want to go a new, different, better, more proven path? From our team, we couldn't drive it because while we use Python, we're not the Python power users with 10 years or more of experience for each developer. That's the reasons why, if you're interested in that, contributing, maybe join the GNU Radio architecture chat and say like, also help us to find like a good path for the larger communities that use Python. I mean, like, bottom line is, if needed, we can replicate the exact identical interface as 3.10. But here's also like an opportunity, not just for the core from C++, but also from a Python point of view or other integrations, Rust, to make an improvement forward.
Great. Thank you all for coming onto the panel, and thank you for the questions. We are running a few minutes late onto the break, so we'll jump straight to that. We'll come back in 10 minutes. It's a slightly late start compared to the schedule, but enough time to get a little bit of tea, some biscuits from the AM break. And please join me in thanking all the panel members and all of the architecture team for their work in the last year.